So what we did in the previous video, we talked about, how exponential function and log functions are related, right? Which is basically log functions are inverses of exponential functions. So what that means, you're basically taking the line y is equal to x, right? This perpendicular line, diagonal line here, and treating that as a mirror and flipping whatever you have on that mirror, right? So anything from this side goes to that side, anything from this side goes to that side, anything that crosses this line, that's the point where they stay in. If you have a mirror, you touch the mirror, your finger is at the same location, right? So we sort of did a really quick intro to logarithms, sort of as a teaser to what will be coming up in the future regarding logarithmic functions and how they're related to exponential functions, right? We'll create something that's similar to, the playlist, to the module that we're creating for trigonometry, right? Start up with the most, basic concept and build up to it and graph it and use logarithmic equations to be able to, or the log rules to be able to manipulate expressions and solve equations and whatnot, right? And again, not sure when that's going to be. As soon as we finish the module for trig, we'll probably jump into logs right away, okay? But until then, hopefully the previous video was a nice little teaser, a nice little introduction to logs. Now, while I have, this setup right now, another thing I want to talk about is how to solve absolute value equations and how to graph absolute value functions, okay? And this video is going to be, a teaser for this, for absolute value expressions or absolute value functions, because we will create a whole series on absolute values as well. But because I've been getting requests to do this, I figured I'd do a little intro to this as well. And I wish I could freeze time and create all these modules and release everything in one shot, but it takes time to do this, right? And I know, people are, maybe struggling with this concept right now. So hopefully this introductory video, this teaser, will clear up some of the problems you may be having. And if I'm jumping around a little bit, and I will be jumping around a little bit, don't worry, I will be covering this extensively, doing it over, creating a module for this, right? The playlist for this, and taking you through every step. But until I get to it, hopefully this will help you guys out, okay? So let's take this guy down. Just in case these things were too far away. Hopefully they weren't. Let's put this away. Now, we're going to go through this pretty quick, pretty fast, okay? And this is, the sort of little little spiel I give when I'm teaching someone absolute value functions when they've been exposed to a little bit, okay? So again, if we go through this fast, my apologies. I will be, covering the stuff in more detail later on when we put the playlist together for this, okay? Now, in mathematics, we have symbols that tell us to do things to our functions or equations or expressions or base values or however way you want to think about it, right? And one symbol we have in mathematics is the absolute value symbol, okay? Now just imagine if we had the following. Absolute value of 2, okay? And these two lines here are the absolute value expression that we use, right? The operation that we use. So absolute value of 2 means this. It means anything on the inside, right, irrelevant of what it is, As soon as you use this power, as soon as you take the absolute value of it, it becomes positive. That's all it means, right? So absolute value of 2 is 2. Okay. Absolute value of negative 2 is also 2. Okay. So irrelevant of what's on the inside, right, positive or negative, as soon as you take the absolute value of it, it becomes positive. Okay. Simple concept. Some people refer to this as distance. If you're just measuring distance, doesn't make a difference if you're going backwards or forwards. It's how far you were from where you started, right? If you want to think about it this way, if you're standing here, right, you can go in this direction. If we put it on a number line, right, this way would be positive, this way would be negative, right? But let's assume you were standing here and you went 1, 2, 3, 4, 5 boxes here, right, or 5 grid marks here. This would be 5, right? If you went 5 backwards, 1, 2, 3, 4, 5, the distance here is 5. The position might be positive 5, and the position might be negative 5 on a number line, right? But distance you've traveled is 5 either way, right? If you want to think about it this way. I personally don't talk about this too much, because absolute value functions are much larger than that. They're much bigger. So, you shouldn't be restricted to thinking about this as just distance, right? So absolute value functions are a power we have in mathematics that take anything that we have here, may it be positive or negative, as soon as we take the absolute value of it, it becomes positive, right? So if we have the following equation, right, that we're trying to solve, let's say we had x, absolute value of x is equal to 2, right? What are all the possible values that x can be, right? That's what it means when we're trying to solve for an equation. What we do, we say, write a expression here, it could be a function, basically, that's what it is equal to a number, right, or another function, and we try to isolate that variable and figure out what that variable can be, right? In this case, absolute value of x is equal to 2. If we didn't have the absolute value symbols here, then x is 2. That's a given because we're saying x is 2. But we have the absolute value of x is equal to 2. What can x be, right? Well, x can be 2 or negative 2, right? Just the way we did here. So whenever you're solving absolute value functions or absolute value equations, right, the way you should do them is realize that the inside could be positive or negative, right? So what we do is we take this in 2 different directions, positive on the inside, right, and negative on the inside. So positive on the inside means x is equal to 2. That's a given, right? Let's write this bigger so you see it. Negative on the inside means negative x is equal to 2, and then we just divide by negative 1 on this side, divide by negative 1 on this side, so x is equal to negative 2. That's how we solve for this type of equation, okay? And we do this concept for anything that we get here, okay? Let's do it one step further. Let's do another, solve for another equation, which might be a little bit harder, right? Let's do this in blue so we don't get, it doesn't, how far can we go? Can we do it here? Sure, let's do it here. Let's say we have absolute value of x plus 1 is equal to 2, right? Again, we take this in 2 different directions, positive and negative. So positive on the inside just becomes x plus 1 is equal to 2, plus 1 is equal to 2, and we bring the 1 over, so x is equal to, so minus 1, this guy comes over, so x is equal to 1, right? which makes sense. If we plug in 1 here, 1 plus 1 is 2, absolute value of 2 is 2. Easy. The other thing we can do, we can take the negative one, so negative, the whole thing, is equal to 2. The inside could be negative, so negative bracket, the whole thing, is equal to 2. We can either divide by negative 1 right now, or apply the negative to the brackets and make both of these negative. If you divide by negative 1, that's the quicker way of doing it. If you divide this side by negative 1, you divide that side by negative 1. So what you're going to have is x plus 1 is equal to negative 2, and then grab the positive 1 here, bring it to the other side, right? So x can equal negative 3. And x is equal to negative 3 is our second answer to this equation. And it makes sense, right? If we plug in negative 3 here, negative 3 plus 1 is negative 2, and absolute value of negative 2 is 2, right? So absolute value equations have more, or let's rephrase that, absolute value equations could possibly have more than one answer, or no answers at all, right? And you know, for the no answers, sometimes it's a trick question they give you. If we had absolute value of x plus 1 is equal to negative 2, there would be no answer here, because the absolute value, as soon as you apply this, it becomes positive. So you can't take the absolute value of something and have it equal to a negative, right? Let's do something more complicated. Let's do so let's assume we had, you know, a more complicated function. Okay, let's do one more, just a linear function, linear expression equaling something. So let's say we had, I wonder if we can do 2 of these things in space. Let's do this. Let's say we have 2x plus 5 minus 2 is equal to 6. Okay, hopefully you can see that. I think so. So if we had this, again, what we're going to do, we're going to branch this off into 2 directions. We're going to go, this is the positive inside, we're going to take this way, and the negative of the inside, we're going to take that way. Okay. Now the positive on the inside is going to be just whatever is there, which is 2x plus 5, right? That's what was in the absolute value, minus 2 is equal to 6, right? And we just solve for this. So plus 2, so we have 8 on this side, and we've got 2x plus 5. Grab the 5, bring it over, minus 5. So 2x is equal to 3, divide by 2, so x is equal to 3 over 2. Okay? And if we check to see if this works, the number works here, and usually you should check. And actually, let's do the check down here, okay? Because check is something that people, you know, have a hard time doing, laying it out properly. So let's lay it out. We'll check for one of the answers anyway. But for now, let's solve for the negative of the inside, equaling this, okay? So we take what's on the inside, 2x plus 5, and that can be negative, right? So negative of that minus 2 has to equal 6. Okay. So what we do is we apply the negative here. So let's do a separation here. I should have left myself a little bit more room, but let's do a separation. Okay. And what I'm going to do is I'm going to bring the 2 on this side, plus 2 on this side, right? So this side is again 8, but this side I'm going to multiply the negative inside the brackets. So this is going to be negative 2x minus 5 is equal to 8, right? Because the negative applies to both of those. And you know, if you don't know how to solve equations, you know, move around an equal sign in series 3, you know, we put together a whole bunch of videos, right? We talked about this a lot on how to move around an equal sign. Okay, so if some of this stuff is, you know, you're curious of what's going on, that's where you want to be at, right? But we're going to assume that you already know how to do that because you're dealing with absolute value expressions or functions, right? So what we're going to do is we need to get x by itself, right? So we're going to go plus 5 here, plus 5 here. So now we got negative 2x is equal to 13, right? 8 plus 5 is 13, and then divide by negative 2, divide by negative 2. So x is equal to negative 13 over 2. Okay, these are our solutions. According to what we've done, if we plug in x is equal to negative 13 over 2 here, then if we simplify this, that should equal 6. We should check though, right? So let's do a check on this. Let's do the check in green. Okay, hopefully I can fit it all in here. And the way you lay out checks when you're trying to check for an equation, it's really important to do the layout properly, because a lot of people set it equal to it and then solve it, reduce it, and then they go, oh, it equals. But you can't assume something equals something else until you've checked to see if it equals it, right? So the way you do checks is this. Write down check. Now, which one do we want to check? I think we have enough room to check one of these. So let's check the harder one, negative 13 over 2, and we'll do this one just using mental mathematics. Okay, so this means when we're checking, we're going to plug in negative 13 over 2 on this side of the equation wherever we see x. So what we do is we call this the left side, and we call this the right side. And you know, the short version of this is ls and rs, right? So we usually say just ls, left side, and rs. Sorry, the left side and the right side, right? So what we're going to do is we're going to take whatever was on the left side of the equation, write it here with replacing negative 13 over 2 for x. So we're checking for x is equal to negative 13 over 2. So this is going to be absolute value of 2 times negative 13 over 2 plus 5 minus 2, right? Oops, there should be absolute value there. Don't forget your absolute values, right? The symbols. 5 absolute value minus 2. That's what's on the left side with the negative 13 over 2 replacing the x. On the right side, we just have 6. Okay, so if this answer is correct, this side has to reduce to 6. So what we do is 2 times negative 13 over 2, 2 kills 2. So this becomes negative 13 plus 5 absolute value minus 2. Negative 13 plus 5 is going to be negative 8. So absolute value of negative 8 minus 2. Absolute value of negative 8 is 8, right? As soon as we apply the absolute value symbol, this becomes 8, right? Hopefully that's still on the board. Minus 2 is equal to 6, which is correct, which is what the right side of the equation was, right? So our left side is 6, our right side is 6, so this is works, right? If we're going to do it for this one, 3 over 2, right? If we plug it in, 2 times 3 over 2, 2 kills 2, so this is 3. 3 plus 5 is 8. Absolute value of 8 is 8. 8 minus 2 is 6, so that works as well. Okay. Let's do, you know, one more step, one more, you know, level of complication, and then we'll leave it that for solving the equations, for absolute value equations. So So let's take one level difficulty higher. Okay, let's take a quadratic equation, one of my favorites that I use a lot, right? And let's solve for that. And when looking at that, thinking that it's an absolute value function, right? So let's assume we had absolute value of x squared plus 5x plus 6 is equal to 0. Okay. And if you watch series 3, A and B, you would have seen this a fair bit. And actually, we've done this a little bit in ASMR math as well. We're talking about the power of 0, right? What it means, what that allows you to do, right? Which is extremely important concept to comprehend, to understand when it comes to solving equations, because 0 allows us to do something that no other number allows us to do, right? Which is when you have things multiplied together to give you 0, you can split them up, right? So what we do for this is, again, it's an absolute value, so there's two possibilities, two branches. The inside could be positive or the inside could be negative, right? So we break this up to the positive version and the negative version. And this is what we're going to do whenever we encounter an absolute value equation. And I'll show you how this works for absolute value functions, right? So we take the inside could be positive. So I don't need to put it in brackets because just it is what it is, right? So this becomes x squared plus 5x plus 6 is equal to 0. And to be able to solve for something like this, all we need to do is factor it. Two numbers that multiply to give us 6, add to give us 5, or 2 and 3. So we split this up, factoring it using just simple trinomial factoring. X plus 2 plus 3. And we use the power of 0. When we have two things multiplied together to give us 0, we can split them up, set each one equal to 0. So x plus 2 is equal to 0, x plus 3 is equal to 0. So x is equal to negative 2 and x is equal to negative 3. Okay. These are two of the answers we have right now. Okay. And we can test them. We can plug in x is equal to negative 2 here. Negative 2 squared is 4. 5 times negative 2 is negative 10. 4 minus 10 is negative 6. Plus 6 is 0. This side is equal to 0. That side is equal to 0. So we know that's going to work. And that one is going to work as well. Negative 3 squared is 9. 5 times negative 3 is negative 15. 9 minus negative 15 is negative 6. Negative 6 plus 6 is 0. This side is 0, that side is 0. So we know both this and this work, right? Now what we do, we take a look at this and go down the negative branch. And the negative branch says this side has to be negative, right? So what we do is we go negative x squared plus 5x plus 6 has to equal 0. Okay. And what we can do now is divide both sides of the equation by negative 1. So if we divide both sides of the equation by negative 1, we get x squared plus 5x plus 6 is equal to 0, because 0 divided by negative 1 is 0. And what we have now is exactly the same thing we have here. So etc., etc., we're going to get the same answers. Right? So the positive and negative of this give us the same answers. Okay, which is, something simple that I wanted to do, to show you. Now, if on the other side was anything other than 2, then this side would have been, the answers we got here would have been different than the answers we got here. Okay, and we would have to check those answers as well. And that's all you do, because if we had negative here, we would divide this side by negative, and whatever number was there, the sign of that would have changed. If it was negative, it would have been positive. If it was positive, it would have been negative, right? I'm jumping over a few different concepts here. And if you're doing this in school right now, hopefully this stuff is familiar to you and you know what I'm talking about. And this is sort of a summary of, how you do these things, right? Now, you know, there are more equations that we end up dealing with absolute values, you know, when we come on this section in grade 11, I guess, or grade 12, some places. But we'll leave those ones alone when we, you know, for when we create a full series for this. What I want to show you is how you graph absolute value functions, and we're going to do a simple function because I haven't created you know, a whole series on how to graph functions, or we have a little bit, but I haven't really talked about functions, defining functions very well, and I do want to do that before I tackle this in depth. Okay, so let's just take this down. Graph, you know, a basic function. Okay, and you'll see how this works, and it's pretty sweet actually. It's really neat the way it works. So let's assume we have a linear function. Okay, we have y is equal to absolute value of 2x plus 3. Okay,